Mesopotamians, 400 BC. The Mesopotamians were the first group to make long-term written records. One idea that originated from was the idea of dividing a circle into 360 degrees. One of the most important ideas that the Mesopotamians created was the calendar. Egyptians, 4000 BC. The Egyptians are indeed different from Mesopotamians. The Egyptians developed a calendar so they could predict the Nile flood. They also used astronomy so they could align temples and monuments. An example of one of their temples is the Great Pyramid. Stonehenge, 2100 BC. The Stonehenge time period consisted of stones that resulted in an ancient astronomical calculator. If one would sit in the center of the structure, you will have a clear view of the summer solstice. Chinese, 466 BC. The Chinese made observations and later recorded eclipses. These records survived 900 solar eclipses and 600 lunar eclipses. Another record they had were conspicuous astronomical events such as meteor showers, which are sometimes known as guest stars and comets. The Chinese also determined accurately the length of a year. Thales, 624 to 546 BC. The Thales time period had the first scientists in history. A machine was created. This machine accurately predicted the movement of the moon and also the planets. They also made the antikytherial machinism. This is an ancient analog computer designed to predict astronomical positions and eclipses, calendar, and astrological purposes. Pythagoras, 582 to 500 BC. Pythagoras and his students developed a model of the solar system. This model introduced the celestial bodies produced as spheres in circular paths. The Pythagoreans introduced that not a flat earth but a round spherical earth was not stationary but rather moves unseen. Central fire each 24 hours. They also believed that the planets, sun, and moon make harmony, but their reasoning to why we don't hear the harmony is because we have constant noise and cannot compare it to a silence that we don't have. Babylonians, 500 BC. The Babylonians used long records of observations to find regularities and patterns in the movements of the moon and planets. From the dates of various configurations, they found every planet synodic period. They also discovered, along with measuring long intervals of time needed for a planet to return to the same position. These later on helped with predicting other positions of the planets.
Aristotle, 384 through 322 BC. In the Aristotle time period, they supported Pythagorean's idea of the claim that falling objects go to the center of the earth, leading to his arguments with the earth being spherical and not flat. Other planets must be also. They also came up with the very well-known idea of the world being composed of four famous elements, being earth, fire, wind, and water. Aristarchus, 810 through 230 BC. Aristarchus applied geometry to the study of astronomy. They also found it to be possible to use geometry to find distance and also the size of the sun and moon. A method was improved and carried out by Hipparchus, which was finding the diameter, both angular and linear, of the moon.
Eratosthenes, 276 to 195 BC. Eratosthenes used geometry to calculate the size of the earth. It was also figured out that it will be noon at day when the sun is directly overhead. His method was using sound and the astronomical measurements and were accurate and correct.
Hipparchus, 190 through 125 BC. During this time period, people often said he held the greatest astronomer of antiquity. In about 134 BC, a new star was discovered that increased in brightness that everyone can see from anywhere and everywhere. The earliest catalog of bright stars was created. During this time period, they also estimated precision shifts of vertical equinox 1 degree every 78 years. Mayans and Mesoamericans, 1818. The Mayans kept track of the sun and moon. They also studied the rising and setting of Venus and built buildings aligned to positions of the sunrise and sunset. Ptolemy, AD 127 through 151. Ptolemy competed of a system that could accurately account for planet motions. This system proposes of the path of a planet that is a combination of motion on two paths. Arabs and Muslims, 700 through 1200 AD. According to this time period, the sky was a constant study for timekeeping. They also determined longitude and latitude. One instrument that was used was a sextant. A sextant is used to calculate the positions of certain stars or direction. Copernicus, 1473 through 1543. Copernicus proposed the first fully developed heliocentric model of the solar system. Retrograde motion of the planets is caused by the motion of the prom which observes the planet. Brahe, 1546 through 1601. Brahe had accurate and precise observations for his time, even without the use of a telescope. Brahe also built instruments for the use of longitude and latitude. Galileo, 1564 through 1642. Galileo was one of the first to be brave and study the sky without the help of a telescope. He discovered Venus had phases like the moon. He also came to the realization that these discoveries gave support with the heliocentric model. Kepler, 1571 through 1630. Kepler discovered the planets of the solar system followed elliptical paths, which are not circular paths. Kepler approved horoscopes and then became most accurate in his time period. He believed the sun was the center with planets orbiting it. Newton, 1643 through 1727. Newton discovered that starlight and sunlight are the same. He also speculated that stars would have their own systems of planets orbiting them. Edmund Halley, 1656 through 1742. Edmund Halley assigned numbers to stars. He also saw that Venus and Mercury could be used to discover the real size of the solar system.
Einstein, 1879 to 1955, formulated the theory of relativity, which revolutionized modern astrophysics. He received the Nobel Prize in 1921 for 1905 work on the photoelectric project. Niels Bohr, 1913, created the atomic model. He had a chemical named after him, borium. Wolfgang Pauli, 1956, proposed the existence of a hitherto observed neutral particle with small mass, which he called the neutron. Werner Heisenberg, 1924 to 1927, developed the matrix mechanics formulation of quantum mechanics. He studied behind other great scientists to develop the atom. Edwin Hubble, 1930s, He showed there were more galaxies. He created the Hubble sequence, which is still overlooked by scientists today. George Lemaitre, 1931, father of the Big Bang, explored logical consequences of an expanding universe and proposed it originated at a finite point in time. Robert Oppenheimer, 1947 and 1966, devoted research to energy processes of subatomic particles, including electrons, positrons, and cosmic rays. He was a part of the Manhattan Project. Penzias and Wilson, 1964 to 1965, used large horn antennas to map signals from the Milky Way when they discovered the CMB. CMB is a noise left from the creation of the universe. Fred Hoyle, 1945, introduced a new method for solving the equations determining the structure of a star. Other rare elements could be explained by supernovas. Armstrong and Aldrin, 1969, first men to walk on the moon. They took samples of the moon rocks and dust.